Marcos Jr. says the construction of Metro Manila's
progress of the Metro Manila Subway Project.
The streets of Metro Manila never truly sleep. Before dawn breaks, buses are already packed, trains are overflowing, and millions of commuters begin another exhausting race against traffic. Every day, valuable hours disappear inside cars, jeepneys, and crowded stations. For decades, this congestion has been accepted as part of everyday life. But beneath the city's relentless traffic, something extraordinary is taking shape, hidden from most people above ground. Deep below the bustling roads, massive tunnel-boring machines are carving their way through layers of earth. Entire underground stations are emerging where there was once nothing but soil and rock. Thousands of engineers, construction workers, and planners are working around the clock on a project so ambitious that it promises to transform how millions of Filipinos move across the capital. This isn't simply another railway extension. It is the largest underground infrastructure project ever attempted in Philippine history. The Metro Manila Subway represents more than just a new transportation system. It marks a turning point for a nation that has struggled with urban congestion for generations. Stretching across some of the busiest districts in the country, this modern rapid transit line is designed to connect key business centers, residential communities, government institutions, and even the country's main international airport. For years, many believed that an underground railway in Metro Manila was nearly impossible. The Philippines sits along the Pacific Ring of Fire, one of the world's most active seismic zones. Earthquakes are common. Heavy monsoon rains frequently flood low-lying areas, and the soft alluvial soil beneath parts of the city presents enormous engineering challenges. Add to that the dense maze of utilities, roads, buildings, and existing infrastructure, and the task becomes even more daunting. Yet despite these obstacles, construction moved forward. The vision is remarkable. Once completed, the subway will span approximately 33 kilometers with numerous strategically located stations serving some of Metro Manila's most important districts. It is expected to dramatically reduce travel times that currently consume hours each day. A journey that might take nearly 2 hours by road during rush hour could eventually be completed in a fraction of that time. The project also introduces an entirely new chapter in Philippine engineering. For the first time, the country is building a fully modern underground metro system using advanced tunneling technology similar to those found in cities like Tokyo, Singapore, London, and Seoul. Gigantic tunnel-boring machines, each weighing hundreds of tons, are quietly digging beneath neighborhoods without causing widespread disruption at the surface. Their precision allows crews to construct tunnels while minimizing impacts on the communities above. But creating an underground railway isn't simply about digging tunnels. Every station must withstand earthquakes. Flood protection systems must be carefully designed. Ventilation, emergency evacuation routes, power systems, and sophisticated train control technologies all have to work together flawlessly beneath one of Southeast Asia's busiest metropolitan regions. The deeper you look into this mega-project, the more astonishing it becomes. Behind every tunnel lies years of planning. Behind every station is an engineering puzzle unlike anything the Philippines has tackled before. And behind every meter of progress is the hope that one day Metro Manila's daily commute will no longer define life by traffic, but by opportunity. The need for a subway in Metro Manila did not appear overnight. It was the result of decades of rapid urban growth that steadily outpaced the city's transportation network. As the population expanded into one of the largest metropolitan areas in Southeast Asia, roads that were once considered adequate became overwhelmed. New highways were built, flyovers multiplied, and rail lines were extended, Yet traffic seemed to grow faster than every solution that was introduced. For many residents, traffic is no longer just an inconvenience. It has become a way of life. Daily routines are planned around congestion rather than distance. A destination only a few kilometers away can take well over an hour to reach during peak periods, turning simple errands into lengthy journeys. Businesses factor traffic delays into delivery schedules. Families sacrifice valuable time together, and countless opportunities are lost to hours spent sitting in unmoving lines of vehicles. As Metro Manila continued to grow into the country's economic and financial heart, the pressure on its aging transportation network became impossible to ignore. The challenge was never simply about the number of cars on the road. Metro Manila is home to millions of people living, working, and studying across a dense urban landscape where space is increasingly limited. Expanding highways indefinitely was neither practical nor sustainable. Every new road project offered temporary relief before traffic volumes surged once again, highlighting a fundamental reality. The city could not build its way out of congestion by staying above ground alone. Today, millions of people travel across Metro Manila every single day. Office workers leave home before sunrise, hoping to beat the rush. Students spend precious hours commuting instead of studying. Delivery trucks crawl through congested streets, while emergency vehicles often struggle to navigate packed intersections. Economists estimate that traffic congestion costs the Philippine economy billions of pesos every day through lost productivity, wasted fuel, delayed deliveries, and reduced business efficiency. Time has become one of the city's most valuable and most wasted resources. Building more roads alone could never solve the problem. Every new lane eventually filled with more vehicles, creating a cycle that repeated itself again and again. Urban planners realized that the only sustainable solution was to move large numbers of people without relying on roads already pushed beyond their limits. That meant looking underground. Unlike elevated railways, which require large structures above existing roads and neighborhoods, an underground metro preserves valuable surface space while allowing trains to operate independently of traffic, weather, and road congestion. Passengers can travel across the city without waiting at intersections or being delayed by accidents and bottlenecks. It is the same approach that transformed transportation in many of the world's largest cities, and now the Philippines is following a similar path. But deciding to build a subway was only the beginning. Turning that vision into reality proved to be an entirely different challenge. Before a single tunnel could be excavated, engineers had to understand what lay beneath the streets. Extensive geological surveys were carried out to examine layers of clay, sand, gravel, and rock hidden below the city. Every section of the route presented different conditions, requiring engineers to carefully map underground utilities, foundations, water tables, and existing infrastructure. Even the smallest mistake could threaten nearby buildings or interrupt essential services above ground. One of the greatest concerns was water. Metro Manila experiences powerful typhoons and intense monsoon rains every year, and flooding has long been a challenge in several parts of the capital. Constructing an underground railway in such an environment demanded extraordinary planning. The tunnels and stations had to be designed with sophisticated waterproofing systems capable of resisting groundwater infiltration. Pumping facilities, drainage systems, and flood barriers were incorporated into the design to protect passengers and critical equipment, even during severe weather events. Then came another obstacle that engineers could never ignore: earthquakes. The Philippines lies along one of the most seismically active regions on Earth. Every major structure must be designed with earthquakes in mind, but underground railways require an even higher level of protection. The subway's tunnels, stations, and supporting structures are being engineered to withstand powerful seismic activity. Flexible joints, reinforced concrete structures, and advanced monitoring systems are all part of a design philosophy that prioritizes resilience as much as efficiency. Rather than simply surviving an earthquake, the goal is to allow the system to continue operating safely or resume service as quickly as possible after inspections. Construction itself became a carefully choreographed operation. In some locations, enormous station boxes had to be excavated in the middle of densely populated neighborhoods, without bringing surrounding communities to a standstill. Roads had to remain open, utilities had to keep functioning, and nearby businesses needed to continue operating while massive construction unfolded just meters away. To accomplish this, engineers relied on a combination of modern excavation methods, temporary support structures, and continuous monitoring. Sensitive instruments tracked even the slightest movement of nearby buildings and roads. If any unexpected settlement was detected, construction teams could respond immediately before minor changes developed into larger problems. Meanwhile, beneath the surface, giant tunnel-boring machines slowly advanced through the earth. Unlike traditional blasting techniques, these enormous machines cut through soil with remarkable precision while simultaneously installing concrete tunnel segments behind them. As the machine moved forward, a finished tunnel gradually emerged, ring by ring, creating a stable underground passage strong enough to serve generations of commuters. It is slow, meticulous work. Progress is often measured in just a few meters each day, yet every rotation of the cutting head brings the project one step closer to transforming the daily lives of millions. While the streets above remain crowded with traffic, an entirely new transportation network is quietly taking shape below. One engineered not only to solve today's problems, but to prepare Metro Manila for the demands of the future. As construction continues beneath Metro Manila, the scale of the engineering becomes even more impressive. This is far more than a collection of tunnels linking one station to another. Every section of the subway has been carefully designed as part of a highly integrated transportation system where thousands of individual components must function together with absolute precision. From the tracks beneath the trains to the software that controls their movement, nearly every aspect of the project reflects decades of lessons learned from some of the world's most advanced metro systems. One of the first things passengers will notice is the stations themselves. Unlike many older subway systems built decades ago, the Metro Manila Subway is being designed with accessibility, safety, and efficiency at its core. Wide concourses will allow commuters to move more freely, while elevators, escalators, and barrier-free pathways will make travel easier for elderly passengers, parents with strollers, and people with disabilities. Platform screen doors will separate passengers from the tracks, reducing accidents while improving air circulation and climate control inside the stations. Below the platforms lies an entire world that most passengers will never see. Hidden corridors will house electrical systems, communication networks, ventilation equipment, emergency generators, drainage pumps, and maintenance facilities. Every cable, pipe, and mechanical component has its own designated space, ensuring that routine maintenance can be carried out with minimal disruption to train operations. Designing this hidden infrastructure is just as important as building the tunnels themselves, because a modern subway depends on reliability every single day. The trains that will eventually run through these tunnels are expected to represent a major leap forward for public transportation in the Philippines. Built for high-capacity urban service, they will feature spacious interiors, air-conditioned cabins, real-time passenger information displays, and dedicated areas for passengers with mobility needs. Multiple cars will operate as a single train set, allowing thousands of commuters to be transported every hour in each direction. Unlike conventional railways that rely heavily on manual operations, the Metro Manila Subway will incorporate advanced signaling technology that continuously monitors the position and speed of every train. Sophisticated computer systems will manage safe distances between trains, allowing services to operate at shorter intervals without compromising safety. During peak hours, this means more trains can run more frequently, helping reduce overcrowding and keeping passengers moving efficiently. Safety has influenced virtually every design decision. Emergency exits are strategically placed throughout the tunnels, allowing passengers to evacuate quickly if necessary. Powerful ventilation systems are capable of controlling smoke in the unlikely event of a fire, while surveillance cameras, communication systems, and centralized control centers will monitor operations around the clock. Every procedure, from routine maintenance to emergency response, has been planned long before the first passenger ever boards a train. Behind this massive undertaking is an equally remarkable international partnership. The project brings together Filipino engineers, architects, construction workers, and government agencies, alongside experts from Japan and other countries with extensive experience in underground railway construction. This collaboration is not only helping deliver the subway itself, but is also transferring valuable technical knowledge to a new generation of Filipino professionals. Skills developed during this project may shape future infrastructure developments across the country for decades to come. Progress, however, has not always followed a perfectly smooth path. Like many megaprojects around the world, the Metro Manila Subway has faced delays caused by land acquisition, utility relocation, global supply chain disruptions, and the COVID-19 pandemic. Construction schedules had to be adjusted as restrictions affected labor availability and the delivery of specialized equipment. Yet despite these setbacks, work gradually resumed, and the project continued moving forward. Every completed excavation, every finished station box, and every newly installed tunnel segment represents years of planning and coordination. Above ground, commuters may only see construction fences, cranes, and heavy equipment. But below those barriers, a complex transportation network is steadily coming together piece by piece. Perhaps the most fascinating aspect of the subway is that much of its progress remains invisible. Unlike a towering bridge or a soaring skyscraper, an underground railway reveals very little until it is almost complete. For years, millions of people have passed construction sites without realizing that enormous machines were quietly reshaping the landscape beneath their feet. It is a reminder that some of the most transformative engineering projects are not always the most visible. They are the ones working silently below the surface, preparing for the day they finally emerge into public life. With every passing month, the vision becomes a little clearer. The tunnels extend farther. The stations take shape. The systems that will eventually power one of Southeast Asia's newest metro networks are gradually being installed. The project is no longer just an ambitious blueprint. It is becoming a reality, one section at a time.